All right, guys, welcome to another KevCAM night class here. Tonight's kind of a little bit of a unique night. We're going to kind of review back over some of the older parts that we have done and kind of show you guys how you guys can save yourself a lot of programming time using the SolidCAM 3D options in there. So tonight, got Brendan McKenna helping out with any questions, concerns, comments that come up along the way. And we actually have a pretty special surprise at towards the end that I'll mention, and really it's something that I've been pushing hard for a long time from the CEO of the company, and he's wiggled on it for us. So we'll keep that for the end for you guys for a nice little surprise. But those that are new here, thanks for joining us. Both myself and Brendan really like interacting with you guys and talking with you guys. So.
Yeah, absolutely. No question about it. Happy to be here. And yeah, Kevin, I was just going to say before we get started, maybe just some housekeeping stuff, or is that what you were just going to talk about?
Yep, go ahead.
Oh, cool. All right. Yeah, sorry to steal your thunder there.
No.
I was just going to say everybody's in listen-only mode at the moment, just to kind of eliminate background noise. But as we move through this presentation, if you do have questions, about 3/4 of the way down on the GoToWebinar page or control panel, you will see a questions area. If you do have questions along the way, just feel free to type those in. I will either answer those as they come up, and if I can't answer it, Kevin certainly will, and we'll bring those up as we move along. And then, of course, at the end, we'll have a Q&A. So. But yeah, as Kevin said, we really have a great promotion. Sean Maimutas, our COO of SolidCAM, has allowed us to do something, really very unique and very special here tonight. And if it turns out that there's something that you'd like to see or maybe add to your product portfolio, we've got some really interesting information for you at the end. So. Hang tight. We'll talk about that, and again, I'll turn that back over to Kevin.
All right, thank you, sir. All right, so like Brendan said, it's kind of an exciting one, kind of the Christmas special here. But like I said, for those of you guys that are new, this is solely designed for you guys to get better with machining, excuse me, and SolidCAM in itself. So it's just not SolidCAM oriented here. It is full machinist going forward here. So with that being said, if you guys do have ideas, I've gotten a lot of great ideas from you guys, and that's kind of where we're basing these classes out of here. So if you guys do have ideas, for those of you that are new, we'll send you a free hat and t-shirt. And if you just want, you guys can email me at kevin. Let me do copy this out here. At kevin.rankle@solidcam.com, and my email address is in the GoToMeeting chat. And then also, all of our classes are recorded, so if you guys need to look back on it, you guys can go over to the SolidCAM, or if you go to the YouTube and type in KevCAM or go to the SolidCAM University, here are all the videos that we've done in the past. There also is some tips and tricks one in there that are, just a few minutes long. Basically, you guys asked me to create a couple videos. This 3D stock, I can't remember who mentioned it the other day, but just how to bring a 3D stock, a casting stock into their turning and milling project. So I made a quick little video on how to do that there. So definitely come here. I will put the link to the YouTube channel in there for you guys, and definitely subscribe, so that way any new movie that I make will pop up in your updated list. So okay, with that being said, we'll get the ball rolling here. So what I was kind of saying at the beginning is we're kind of doing a little bit of a recap of what we covered over the last 5 months, and well, I guess not really do a recap, but I'm going to show you a much better, faster way, programming-wise, using the 3D iMachining and HSM. Now, for how many of you guys have just the 2.5D professional package right now? Or does everybody in here have 3D?
Yeah, you know, just looking through the list here, Kevin, of people, I'm not exactly. Okay, great. Yeah, we're getting the feedback now.
Okay, 3D.
I know many of the people that are here, but yeah, so there, you know, some have 3D, some have, you know, 3D milling, but not HSM, you know, that kind of stuff. So
okay, perfect. Okay, so a couple months ago, and I got 3 different examples I want to kind of run through with you guys here. So if you guys remember, if you're new to the channel, you might not remember this part, but this part we actually did with Profile. I mean, we can go ahead and simulate it through here and kind of see what we did here. Probing up our part, kind of machining off the flats there, doing our circles, and cutting up to our part, doing rest material, and then doing our engraving. And then, we also did the plunging pattern around the outside, just as a different way of going about doing the kind of keeping that attached on there. So now what I want to do is I want to kind of bring this part into the, I don't know, the 20th century, as you say. So let me go ahead and close out of this one. And what I did is I just made a copy of that part and basically deleted it, and so we're starting from scratch now. So right here you'll see exact same part, same stock, everything's the exact same. But now what I'm going to do is I'm going to show you guys programming with 3D iMachining and HSM. And it's going to make your life a lot easier for those of you guys that don't have it. So you see I got still my probing operations here for you guys. Now what I'll do is I'm going to do my 3D iMachining, and I'm going to switch this over to prismatic now, and I'm just going to grab a tool. And we got a 1/2 and a 3/8. Let's just go with the, just trying to remember what size radius I actually have in here. Okay, so let's go with the 3/8 cutter here. Okay, so that is it. All they had to do is pick a tool. Let's do save and calculate. And what it's doing right now is I didn't tell it where to machine. I didn't tell it what areas to avoid. I didn't tell it anything. All I did is I picked a tool. Now what it's doing, and you'll see in the calculation here, is it's finding the stock and your SolidWorks model, and it's machining everything off in between. And when you do a 3D iMachining, it's automatically going to leave 15 thou on the wall and the floor. So and the 3D iMachining is, I would say about 75% of it is going to be used for roughing. We'll go over one part where we can just do 3D iMachining and that's it, and we'll just put these at 0. But it's all dependent on the finish that you guys are looking for. So this part, customers are going to see it, other customers are going to see it. It needs to visually be appealing. So we'll come back and lay down some nice paths. So right there, I've just basically machined that whole entire part. Let's just do a simulate here. And slow down, or I can speed up a little bit. And it's always going to try to start at the bottom and work its way up. Now this one we're taking in a couple different passes here. Going down, and that's just to utilize the flute. Now if I would have went with a 1/2 inch, it would have taken full depth of cut. But like I said, I didn't have to tell it a feed rate. I didn't have to tell it spindle RPM. I didn't have to tell it how much to take. I didn't even have to tell it what to machine. It knows how to do this all automatically by itself. And it is going to be whipping through that material there. 12 minutes to cut that down. Now, if I go to my technology wizard, this is basically where you control your feed rates. For some of you guys who might already know, this might be a little bit of a review here. And what we're kind of doing right now is I'm just kind of doing a quick little overview of the 3D professional package here. And then after the first of the year, we're going to start diving into these each individual one. So HSM, each module inside HSM, and then we'll get into HSS, each module inside HSS, and then we'll do 3D iMachining too. So just kind of doing a little bit of overview. Like I said, kind of recapping of some older parts that we've done, but I'm going to show you now how to make your programming time much faster. Okay, so we got our part all machined out. We still have 15 thou on the wall in the floor. If I want to, I can come in here and I can tell it to take it all in one cut. We'll do a save and calculate again, so it's utilizing the full flutes. By doing that, you know, I did move to the yellow range, which is still fine to cut in. No issues, excuse me, issues at all there. Now if we just do a simulate on that, getting, like I said, starting at the bottom and just kind of working its way up here. And I do have my tolerance set pretty tight. That's why it's taking a little bit longer to simulate here. But facing off the top, like what we did with that profile operation, doing the holes, facing off the top there, machining the whole outside perimeter. So it's doing everything for us, which is really nice. So now, like I said, I need to have a visual appearance on this. It needs to look pretty. If you see, like right here, when we're doing the D-slot tricoidal with that separation channel right there, we have a lot of the D-slot tricoidal movements. So you're not going to get the prettiest looking finish on there. If it's an internal part no one's ever going to see, it's definitely going to meet specs by all means. So it definitely will wouldn't matter there. But like I said, we want to make it look pretty. So now what we're going to do is we're going to come back and do an HSM. Now, it's just as easy as 3D iMachine. I'm going to do, instead of constant Z, I'm going to do horizontal machining. Going to grab my cutter. I'm going to use that same cutter as used before. And save and calculate. And what it's doing, kind of finding the stock and what's left over here. And now, you'll see we got nice tool path going in there, basically like a contour pocket style. You're going to have a really nice finish on all these areas. You know, if I kind of zoom in just on this top piece right here, just doing it basically a step over, doing a nice flowing line so we're not getting any jerkiness, so you won't have any little polish marks when it just does a straight jump over. If we do a solid verify here, and we get that nice pretty finish going all the way around. Any questions so far on what I've just kind of covered?
Yeah, you know, Kevin, there are no questions so far, but you know, the one thing that I just wanted to say was, you know, when you calculated that, you know, that was super fast. I mean, that happened basically instantaneously.
Yep.
That's something that is just so cool about SolidCAM. I mean, you know, you don't have to sit there and wait for the thing to chug through all of that extra code.
Yeah.
You know, it just really works through that very quickly.
And it's really nice with the newer versions of SolidCAM. We're utilizing all the cores of your processor. So if you have more cores on your computer, the faster it's going to be. And this particular computer, I'm running i7 8-core processor, so things do calculate pretty fast.
Yep.
Awesome. Okay. So we still have our chamfer. So let's go ahead and we'll just do a profile. And we'll go ahead and chain this guy here. Do our constant Z. Grab, just use our spot drill that we have. Levels. Right there. And technology. I know this is a little bit of review here, but just kind of wanted to get it look like the original part that what we did in a couple months ago. Now I'm just going to do a save and copy here, change my geometry, and let's go ahead and add our engraving like we talked about last week. And for those of you guys who were in last week, it came up where it arcs up at the end. I can't think of the name of what you guys call it, VCarving. That question came up last week for those of you guys that were in the engraving class. It was pulled out back in the early 2015. I was able to talk to development, and after a couple of you guys, I think George, I think you were one asking about it. There's a couple other guys that are asking about the VCarving. Did talk to development. They are pushing for it and actually have already added it in there and will be released in SolidCAM 2016 SP3, so which should be out shortly. So, I mean, that guy goes to show you guys that, you know, if you guys want something in there, you just let us know and we will add it in there for you. Definitely listen to our customers 100%. Okay.
Yeah, you know, and Kevin, just real quick, you know, that's a great point. I mean, you know, I love the fact that you know, again, this is the second week in a row that you and I have been working together on this class, and, you know, it does. You know, we really do listen to people. We listen to all of the suggestions, and, yeah, you know, we take all of those, you know, all of those things. We really want to make sure that you know, you're being heard, and, you know, that's being worked on. So, you know, again, great point. And George, yeah, we will have that covered for you, you know, very shortly.
Absolutely. All right, let's get that set up, and we'll run this through Machine Sim. And then what I'm going to do is I'm going to kind of bring up that other part here and show you the difference. So let's go ahead and do Simulate, Machine Sim. Okay, so let's slow it down a little bit here. Okay, probing up our part and utilizing our iMachining. So we can speed up a little bit here. Doing that helical entry, getting that face topped off there, and using that HSM and get a nice pretty finish, engraving, and we're done. So,
hey Kevin, yeah. Not to interrupt you here, there was a question that says, now engrave with a bridge. I could not do that text. There was too much code. Any fix for that? I'm not quite sure.
Bridge, is that like the font that you're looking for, Chris?
Oh, Bridgeport.
Okay. It all depends on your machine size, on what it can hold for engraving.
Yeah, memory limitations. Yeah, that could be, you know, it could be a problem depending on memory size. You know, that comes up a lot.
Yeah, so Georgia, what I would recommend doing, or I'm sorry, not Georgia, Chris, is using the DNC and drip feeding it into your machine. That way you don't have to worry about any memory at all. Using the OBD, what is that? Not the OBD2 port, that's in a vehicle.
RS-232.
Yeah, there you go, RS-232. Using that port, and then you can drip feed it in there. Okay. So,
and actually, Kevin, just to continue on that point, just very briefly, there are some things that we can provide for that as well. If there's a, I'm getting massive text messages through my phone. Sorry about that. I apologize. There's, you know, there are some things that we can help with you as for that as well. So if there's, you know, if there's DNC requirements, you know, we can point you in the right direction.
Yeah,
so,
absolutely.
Yeah, we can take that offline, but you know, we can certainly do that.
Okay, so what I want to do here is I'm going to actually do a screenshot of what we have here. And I don't know if those of you guys that use Jing or not, but Jing is a great screenshot product. Capture image. Okay, so I'm just going to kind of push this off to the side just for right now. And I'm going to close out of here. Tools, SolidCAM, and we'll go recent parts. And we'll bring up that original one that we programmed earlier. Now you guys see, when I was programming that part, you know, I didn't have to pick any geometry. I didn't have to pick feed rates. I didn't have to do basically anything. All I had to do was pick a tool. You'll see that we have quite a few more operations using the old traditional way right here versus using the 20th century way, I guess you could say. And the cycle time is going to be much, much faster using your 3D machining, even though that we only have a 2D part right here. They've added that prismatic feature in there just for this stuff that we're kind of covering right here. So even though if you guys aren't working on a 3D part, and by all means this is definitely a 2D part right here, you can utilize that 3D functionality to make you more proficient at programming. So I mean, this part, you know I was kind of talking as I was doing the profiling here and kind of explaining what I was doing, but when we have an hour right here into this part right here versus right here, I just programmed this part, you know, live for you guys, and we did it, you know, in 15 minutes. So you guys are going to save a ton of time, programming time, also, and machine time, and it's going to be a lot easier on your workpiece material, your spindle, all that stuff. So, okay, enough blabbling there. Let's go on to our next one here. Close out of here, and let's go to our other one. So you want to do standard. Okay, so do any of you guys remember this part right here that we did? I think, yeah, this was right before the 2.5D Pro one that we covered. But you know, right here we got the same part that we did before, still in the vise. We got our face mill, contour, pocketing, drilling, basically everything that kind of comes with your 2.5D standard stuff. So you got some pockets, we have some open pockets here, we have some face milling, some drilling, tapping, all that good stuff. Sorry, George, I didn't, I'll get the difference of cycle time right here for you. George was asking what's the difference in cycle times. So right here, we will, let's go ahead and do a simulate and kind of show what we did here. Okay, face milled off, countersinking, doing our holes, and we're done. And let me do a solid verify, and let's get a cycle time of what we have right here. So 40 minutes, 55 seconds to do this part. Like I said, not a lot of, you know, heavy machining here, but a lot of tedious work. You know, when we were actually chaining this stuff, for instance, I'm just going to go into one of these operations. Let's do a show. Looks like we were kind of clearing this material off right here. So what we did is we did a profile line with a clear offset over here, chaining that up. For this particular operation right here, doing a finish pass, and let me just do a show. There we go. So this one right here, we had to come through and chain all this geometry right here to get that going. And like I said, it's not a hard part by all means. And I'm sure some of you guys are looking at this and like, I can do that in my sleep. But it just does take a little bit of time to program. And George, did you remember that number? It's 40 minutes and some seconds. Let me write that down. 40, here, let me have to play it through again here. 40 minutes and 55 seconds, so I'll write that down. Okay, and you can see we got a lot of toolpath going on here, getting that material out of there, face milling it off, chamfering, all that good stuff. So now, let's go ahead and program this part live for you guys using the 3D machine and the HSM. So I'm going to close out of here. Tools, SolidCAM, recent parts, and standard part 2. Like I said, all I did is I just did a save and copy. The other one didn't have probing, so maybe we'll just take the probing off of this one. Okay, so we're starting out fresh right here. So what we'll do is start off with a 3D machining. And just, we'll turn it to prismatic here, grab our tool. We just got one to choose from. Like I said, don't have to touch anything in here. If I want to, I can do, you know, more than one step, looks like I can't because I don't have enough flute length, so we'll just change it back to automatic, taking 2 equal steps. You know, leaving 15 thou on the wall, done deal. Save and calculate. And like I said, what it's doing is it's processing, looking at stock versus target, and I forgot to do one thing here. Since I have my fixture in there, it looks like it don't have to worry about it. In your geometry, if you guys do have a fixture in there, you can just turn on your fixture collision and put a clearance in there of, you know, even 1 thou, and your tool will stay out of contact with your fixture within 1 thou, or, you know, if you wanted to leave a 5 thou in there or whatnot. Okay, so let's go ahead and simulate this. And like I said, starting from the bottom, kind of working our way up, doing that morphine spiral, getting all that material out of there. And like I said, that was, I mean, this is just one operation where we had, what, 15, 20 operations in our other one to do this exact same part. Same tools, everything's the same. The only thing I'm changing is the machining method right here. So we got a fully finished part right here, or I shouldn't say finished because I left the wall offset at 15 thou. So, I mean, you guys seen what I did. Just pick a tool and that's it. Real simple, easy. Now, if we're going for appearance on this one, we can definitely come in here, add our HSM, and just grab that same tool, save and calculate. And now let's go ahead and simulate. And getting that all nice and finished there. So, I mean, real easy, simple to use, guys. Like I said, it's kind of taking machining to the next level, getting going through here. Now what I'll do is I'll come in here and just do a select here. Okay.
So Kevin, as you're moving through this, I think there might be a a relative question on prismatic work on a 2.5D Bridgeport machine.
Oh, absolutely. Yes. Not an issue at all. You will have to run that to drip feed it just because the Bridgeports are pretty limited. The Bridgeport and the some of the Sharp machines are pretty limited on memory in there. A, you can either get more memory, or B, like I said, drip feed it on there. But it definitely does work. And the nice thing is with, Chris is using, I know you guys can't see the questions that are coming in, but Chris is running a Bridgeport machine. So that's nice because what we do is we take into factor what machine we're actually using this on. And this particular one, I'm running it on a Haas VFSS. But by coming in here, we have all different, well, I even have a Bridgeport Easy Track right there. It's just adjusting feeds and speeds. So we know your machine by you giving us the max feed rate, max horsepower, and max spindle RPM, it automatically compensates for that Bridgeport. I kind of wish I had that one video. It's a old.
Oh yeah. The Ken video. Yeah, totally.
It's a video. Well, maybe you can explain.
Actually, well, yeah. In fact, I have it on my system. I can give you control. It's in my webinar downloads. I can do that for you if you'd like. But yeah, the question that we get all the time is, can this apply to my older machines, or does it have to be a brand new machine, to take advantage of this? And, absolutely not. I mean, you can, the idea behind everything that we do is to make you more efficient with everything that you have. And so there's a great video of this old, I think it was an old Haas tool room mill, if I'm not mistaken.
Yep, mini mill.
Yeah, right, a mini mill. And this thing was just like, I mean, it should have been a bow anchor.
Let me give us guys one.
Yeah, we can do
here,
that.
and I'll make Brendan presenter here.
Okay, and there we go. Show my screen. And I'll let you take over from here, Kevin.
You'll have to tell me where you got it at.
It was in my downloads from...
Let me do the request keyboard here.
There we go. Perfect.
All right. Yeah, I'll show you guys here. It's a very unimpressive but impressive video.
Well, you know, and that's what I'm talking about. You know, it's really kind of funny. I mean, when you look at all of this stuff and, you know, you just think, well, you know, geez, I don't want to have to go out and buy a brand new, you know, $350,000 high-speed CNC machine. Well, you know what? You don't have to. You know, I mean, yeah, this video is perfect. And yeah, this machine, I think, what was the maximum programmable feed rate was 50 inches per minute.
Yep.
Yeah. Loose spindle bearings, loose, you know, ball screws, you know, and so that first pocket, he did it. They were taking that. They were doing it at 50 thousandths depth of cut. It's 1 inch deep. What was it? 4 hours and 20 minutes or so?
Yeah. No, it was hour. It was right around an hour or something, and he would have to take it down in 50 thou increments. And by the time the tool got to the bottom, that was actually shot.
Right.
You'd have to come back and with a face mill. We are at, and this is live right here. I can't see where we're at. There we are. 53 minutes or seconds. Let me fast forward here. We're at 6 minutes in.
I can move that. Let me move that window for you, Kevin.
Okay. So we're 6 minutes in here, and I think it took you know, 7 minutes to do this part. But the cool thing is he was getting, you know, 1 part per end mill, so you could only do this part 1 time on this old rickety machine. That then we moved it over to iMachining, and we actually cut 7 of these holes, and it didn't wear out the cutter at all. It scuffed the coating, and that's about it. So, yeah, it utilizes any machine out there, Chris, to answer your question. Okay.
Yeah, great point, Kevin. You know, I appreciate you bringing that up because that's, you know, that's a perfect example. You know, you don't have to have brand new equipment to, you know, to run this. It's a, you know, we can make your machine, every single machine that you have, you know, much more efficient just by, you know, again, just, you know, programming it in a different way. It's a really interesting technology.
Yeah, absolutely. Okay, so I'm just going to do those drill holes real quick.
All right, Kevin, I'm just going to stop that video real quick there.
Okay.
And you've got control back there,
yeah,
Kevin?
You guys are back viewing my screen, right?
Yeah, I just want to make sure everybody can see what you're doing.
Yep, okay, perfect. Thanks, Chris.
Perfect.
Okay, so we'll do full diameter. Okay, save and calculate. Drilling out our holes there. You know, I should have done this, but we'll do a hole wizard process. Kind of a new technology right here also. I'm going to tell it I want to grab all the tapped holes. I'm just going to click on one. It's going to find all the tapped holes. And boom, got my tools and toolpath. And do that again here. Hole wizard process and do simple hole. Going to find all 4 of my holes. Boom. Okay, so we got a finished part right now. Let's go ahead and do simulate, and we'll do machine sim for you guys. All right, and we'll go ahead and play this through here. So like I said, I'm machining everything out, basically kind of roughing it out. And like I said, if this is not a visual part that, you know, a visual appearance doesn't matter, we don't even need the HSM. We can just change your wall offset to 0, and it will definitely machine it right up to size. All right, so that's what she looks like, finished product there. If I exit out, let's do another simulate, and we'll just get a cycle time here. So 23 minutes and 42 seconds for that cycle time. And we were at 40 minutes and 55 seconds before. So like I said, not only are we saving cycle time, we're saving programming time, because like I said, all I did right here for my 3D machine is pick a tool. All I did for my HSM is pick a tool. That's it. So we roughed it, finished it, all done deal. Any questions? Concerns? If I can do, let me just do a screenshot of what we got right there. Capture that. And let's go ahead and open up our old one that we did before. And let's see, recent. Okay, so I'm gonna bring up our little screenshot here and kind of match it up right here. We have, half the operations right there and half the cycle time, just by kind of switching from the old 2.5D stuff up to the 3D stuff. So for those of you guys that already have the 3D iMachine and the HSM, definitely here's where to take advantage on your 2.5D parts. So.
Yeah, Kevin, that's a great comparison. I mean, when you look at that side by side, there's just like such a great advantage to that. It's...
Absolutely. Okay, so let's do our Pro part.
And again, the cost of well, okay, so now I'm playing. Yeah, I'm totally being the sales guy at this point, but how can I not do it, right? I mean, that's my thing. But,
exactly.
No, but I'm saying, just the difference in cost, the upgrade cost, it's really not that bad. It's fairly insignificant. And then, again, we're going to, we'll talk about that at the end of the presentation.
Let's get into that, because I don't want, we can say the numbers now, but they're, like I said, at the end, I want to throw them the old, the bone there.
I'm not going to do it. I promised you that I wouldn't. You know me. I have to save it to the end.
Okay, so let's go ahead and do a simulate here and see what we have. Okay, so probing upper part. Face mill off, kind of working on the outside, coming in. Now this one we did use iMachining, but we didn't use 3D iMachining. So right now we already roughed out the outside. We're doing a iRough plus finish right now, which is, a little bit nicer than what, was in 2015. So now we can kind of eliminate 2 operations down to 1 there, and basically kind of getting that material off there. And like I said, with this part, since we are using iMachining in here, we are going to save a little bit of cycle time, but it's going to be more the programming time side of things. Let's speed this up a little bit here. And we're drilling out. I probably have my tolerance set extremely tight right now for this one, so that's why it's taking a little bit longer to simulate. Here, let me just do settings, accuracy, yeah. We'll exit, and we'll do another simulate here, and we'll go much faster for you guys. So I'll verify.
Oh, it's really interesting. It's funny. Kevin, you did, I think you did this earlier, if I'm not mistaken. Plunge milling. That's one of the suggestions. Yeah. So, yeah, we'll pass that along. I'm sure you see that in your email. But yeah, that was. I think a lot of people are doing that. More and more. So yeah, that's a great suggestion.
Absolutely. Looks like we. Looks like when we did this part last time, guys, or I don't remember when we did it a month or 2 ago. I don't know, I must have been playing with the depths when we were talking about something here, but I still didn't even go through all the material. So, like I said, we have about a 41-minute cycle time again, and a slew of operations here. Let me just do a screenshot as long as we have this up right here. Capture that. Kind of push him off to the side for right now. Okay, so that was our kind of our old school way of doing it. Let's get into the best way to do it in 3D. Okay, SolidCAM, recent parts, and we're on part 2. Okay, so we got our part already probed up, and like I said, all it is made a copy of what's going on here. Go ahead and do our 3D eye machining, and just grab our tool, hit the green check box, bark in here, and we can do it all in 3 cuts, or I can do different cuts. So I'm just going to leave it on automatic here. Save and calculate. It's finding the stock, it's finding the target model, comparing them right now, calculating the toolpath for us. And I wonder if I can get my cores up. Oh, I missed. I was going to show them all 4 cores working there. And there we go. We got our part basically completely machined out right there. Now, if I wanted to, I can come in here, change our wall offset to 0, save and calculate. And here, let me see if I can get my cores up fast enough. Let's go to performance, CPZ, resource, CPU. Oh.
Yeah, you know, and that's such a cool feature. You know, if you have open cores, you know, you can take advantage of those unused cores.
Yeah.
Yeah, that's very, very cool. You know, and in fact, if you're on a network, you can actually take advantage of other cores on other computers. So,
oh, absolutely. Yeah, if you guys have a powerhouse computer, when you do the saving calculate in parallel, you can tell it to look at that that hardcore, you know, machine there and compute everything for you. And you'll see right here, you know, my cores have settled down because it's done calculating here, but all 8 of my cores were getting pegged all at the same time. So something that we do that other CAM companies won't do for you. Okay. So
well, you know, just to continue, Kevin, real quick on that, not only will they not do it, well, they could do it, but they charge you enormous money to do it.
Yeah.
And well, it's true, and you know, that's a standard feature in SolidCAM.
Absolutely. So now we're kind of facing off the top there, doing our separation channel, facing off the top there, getting everything decided, and like I said, starting at the bottom and working its way up. So we basically just got that part completely done, and the only thing I have left to do is our slot chamfer down the center and our drill hole. And I forgot to tell it to avoid the fixture. But great joys of having solid verification.
Well, come on. I mean, you know, you've never milled through a fixture before? You know, come on.
We don't want to go there.
I personally have never done that.
Yeah, right. All right, so I'm going to turn on my fixture collision here. I'm going to turn it to, let's just do 5 thou. Save and calculate here. So now you can see my toolpath down here where my mouse cursor is going through the vise. Now it will be avoiding that vise. And for those of you guys that are curious, I'm just running, this is actually on a laptop, Dell Precision 6800 series. So then this computer is actually a few years old too. So now you'll see we're not going through our vise anymore, not crashing in there, and it's picking up where it needs to go. And for some reason, I have the depth is way off. Oh, let me go to lower level. There we go.
Yeah, and you know, Kevin, the obvious question here is, you know, why does the tool go that deep when it knows there's a fixture there? So, you know, you could have told it to avoid that, obviously,
yep.
Right?
Yeah, absolutely. So now we're not going, you know, whoop, off La La Land there. Now it's going right up to the depth, going a little bit past, because right here, let me get a side view. You can see where my wireframe stock is, and it's wanting to go all the way down to the bottom of the stock. Now, if I want it just to go down to a specific area, I can click on that, and it will go down to that specific of an area. But like right now, we have a fully machined part in one operation. The only thing I have left to do is drill. Let's drill those holes out real quick. And drilling. Got those. Grab my drill. And go to the bottom of the part, and I want to do full diameter, and I want to go at 20 thou past. Save and calculate. And now we want to add our, let's see your profile here. Constant Z. Tool, select, and add a, let's use a spot drill for that. Ooh, that might be a little big. That should work. Looks a little funky though. I'm going to fix my shank here. Okay. Profile depth is right there. Upper level is right here. And technology, we'll change it to chamfer. And we use 100 thou of the cutter side. Save and calculate. I don't like it starting on the edge. So what I'm going to do is I'm going to shift my geometry straight in the center.
You know, Kevin, there are two great things that just happened right there. The first one that I saw was being able to change tool geometry on the fly. That would be perfect if you had, let's say, like a regrind or, something like that. You don't have, if you're pulling something from a library, that's fine, but you have full control over all of that information. And then the next thing that you did was you started, instead of from the outside of the geometry, you can put your starting point wherever you want. So,
absolutely.
And it totally applies to everything. It really goes, to that level of control in SolidCAM. You don't have to. I know that there are a lot of other systems out there where they claim, full, everything's automatic. It just does it all for you. Well, machinists don't really want that. I mean, maybe in certain cases they do. Hole recognition, pocket recognition, stuff like that. But when it comes to stuff like this, you want to have that precision control, and that's why SolidCAM is almost that hybrid system, which allows you to have that full control, but also, again, you can dial right into any specific tool path and make that happen. So, there's a lot of real control here that programmers really enjoy.
Absolutely. Yeah, you have full flexibility. Now, let's say, if we go into the die machine, I want to control it. I want to have, right here, we're not locking you guys out of anything. Maybe I want to do a different chip thickness. I can turn this on and do a smaller or larger chip thickness. Maybe I want to do a faster feed rate. It's all right here for you guys. We have the wizard set up for you guys, so it automatically calculates feeds and speeds. If you're not happy with those, or maybe you just want to change up your chip thickness a little bit, it's all right here for you guys. And if you guys aren't seeing this tab when you guys do a iMachining or a 3D iMachining, the modified cutting conditions, let me show you where that is. In your settings, under iMachining is the advanced cutting conditions, and that's going to open up that tab for you. So it's basically just hidden. See 2 or 3 passes. So yeah, absolutely. If you guys want to do this and 5 passes, I can type in 5, and we have 5 passes. Doing a step of 0.3531 right there, and it's going to do 5 passes for us. If we want to do it in 1 pass, it's not going to shank out. So right now it's automatically going to put 2 passes in there for me. one at 1 inch, one at 0.7656. So,
so that'll. Sorry, Kevin, not to interrupt. I apologize, but I was just going to ask. So will that actually, like, so for that chamfer, you've got that. That's a pretty heavy chamfer around that inside pocket there.
Mm-hmm.
So can you say to the chamfer cutter, okay, I only want to, I want to take like, 100 thou at a time and move that chamfer cutter in? Is that what you're saying?
No, this is 3D eye machining.
Oh, okay.
So if we want to take it in multiple passes here, we'll play it through here. So like right now it's set to automatic, but maybe I just want to take, instead of doing 2 passes, I want to take 5 passes. I think it was the question. And it definitely can do that. Not a problem at all. And to kind of go where you're going there, Brendan, is, yeah, we can do that, but since we did the 3D eye machining, everything's already roughed out there. So we're just taking a nice light skim cut all the way through there.
Okay, I see what you're saying. Okay.
I think.
Yeah, because I was almost thinking, like, so if you had like a really, and I'm just sorry about that, Kevin. I was just backing up to the previous question. If you did have a really heavy chamfer, instead of taking that in one full cut.
Oh yeah, you can definitely do that in multiple cuts. Absolutely.
Okay, cool.
And
yeah,
you'll see right here. Here's 3D eye machining. We have a nice scallops going up there.
Oh,
so
there you go.
To come back and just do a finish cut on that would be no issue at all for that, radius cutter that you're using, or angle cutter or taper mill or whatever.
So, and it would probably be preferable to do something like this anyway, right?
Absolutely.
Because all of that, all that material would be out of the way in the first place, and then you just come back with your chamfer cutter and you're all done.
Yep. And then, like I said, I mean, we, for this particular operation, all we really did is pick a tool. I didn't tell it to do, nice little steps, chamfering my part for me. I just told it just to machine everything and do what it can. And now, it roughed it out to come back and just do a nice one easy finish cut all the way through. So
awesome.
And then if we want, we can actually play this through in our machine sim here. All right, and I'll slow it down a little bit. And hey, look at that. My parts in my vise, or in my table. Let me just fix that up real quick. And that's easy enough. It's basically going off the top to the bottom. So what I'm going to do is just get a measurement real quick of the distance. And it is a distance of 6.58. So we'll come into our setup and do our 6.58. Okay. And now we'll do our simulate here, machine sim. And if we want to go all fancy, get the machine, everything all going there.
Fancy pants. Love it.
Any questions that came up for you guys? Or has this been interesting for you guys to see what you guys can actually do with your 3D eye machining and HSM versus instead of using your old 2D strategy? Because that's kind of my main focus for this one tonight, is to show you guys there is an easier way to program your 2.5D parts using the 3D module. Hopefully you guys were able to see that tonight. Anybody? Or do we put you out of sleep? No.
Oh, no. Well, Kevin, I mean, I think the cool part about this whole thing is looking at things like, this so much applies to, like, pocket recognition, open-ended pockets, multi-depth pockets, things like that. I think that would really apply here, unless I'm missing something. But
yep.
This is really, there's a lot here if you're dealing with stuff like that, prismatic parts that require multiple operations. When people think about 3D machining, they're not, they typically think surfacing, and that's not quite what we're talking about here.
No.
So,
yep, not at all.
yeah.
Taking that 3D module and applying it to your 2D parts.
Sure, sure, no problem. So I think we've got a couple of questions here, Kevin. One is from Nick. I mean to say, if I have a 1/4-inch chamfer tool, but I want to do 1/2-inch chamfer. Oh, okay. I see what you're saying.
Yep.
Yeah. So he wants to sort of like creep up the chamfer with a smaller tool.
Yep. And to do that, is it Nick? Yeah, Nick. What you would want to do is do that in HSS. And what you would do is change it from parallel cuts, and I would do morph between 2 boundary curves. And then your drive surface is going to be the actual chamfer, and your start is going to be the top of the chamfer, and your end is going to be the bottom of the chamfer, and you can use whatever size tool that you want. If you want to use a little, 10-thou cutter in there, it will definitely do a spiral working way down and getting that cut that you're trying to go for there. So
Kevin, I get, you know what? You're the man. You're the man. This is awesome. This is so cool. Because a lot of people don't know that. They wouldn't know that feature is available in that particular module.
Yep.
So, that's perfect. I mean,
and if you guys, very cool. If you guys are looking at moving up to, if you guys are just sitting right now and maybe, I think we've seen somebody that didn't have HSM or something. I mean, that's kind of what I kind of give you an overview. I'm sure you guys what's going on, and to kind of lead up to what we've been getting to here is, if there's something in here that is showing that you guys don't have, or even if there's something that we don't have at all, for those you guys that have been sitting through the night classes as a Christmas present, like Brendan was saying, Sean Mamutis, our CEO of SolidCAM, has granted me 20% off for all of you guys. So if there is a specific module that you guys are looking at, or maybe you guys have been kind of on the fence if I should buy it or not, 20%, it's the biggest discount SolidCAM has offered. I finally was able for him to give it to me. So all you guys have to do is email me or email your account manager and tell them you want the KevCAM discount the end of the year, and it's only good up till December 28th. He gave me a deadline, unfortunately. I wish I could give it to you guys all day long. But if there's something in here, or if you guys are maybe looking at machine sim, or maybe just getting 3D machining and leaving all your 2D stuff, we can add that for you in there with a full 20% discount up to December 28th. So hopefully that kind of raises a little bit of eyebrows for you guys. I've been trying to get Sean to kind of do this for a while, and he said finally go for it. End of the year, kind of a Christmas present for you guys. So.
Yeah, absolutely. And that's, again, this is such a great point, because we're, really trying to expose you to, to a lot of the different modules that are available in SolidCAM. And again, we do this very differently. We're not the same old CAM company. What we do is, everything is modular. So, if you have, 2.5D Pro right now and you want to add HSS, totally cool. You don't have to jump up to the next level package that is going to cost you, say $12,000. You just add on what you want. So it's easy to do.
And I might put you on the spot here. What would, if some of these guys don't have 3D machining right now, what would that cost for them to have with the discount?
Sure. So just very quickly, so 3D machining with a discount would be, you're looking at about just a little bit over $3,000. It's really not that expensive.
Okay. Perfect.
So for everything that you're getting, again, when 3D machining is not, like, I think people think that it's just, it's surface machining. Well, it's not. Everything that you showed here tonight, Kevin, is perfect, because, again, you get all of that, that prismatic functionality that comes along with it. So, yeah, I mean, it would be worth taking advantage of if somebody does want to see it. We do have a couple of questions, Kevin, if I can go back to those. And I know we're at the top of the hour. We'll wrap up pretty quick, but let's see. There was one.
W.M. Anderson, he was asking about HSM on rest material, and that's kind of what I got showing up on the screen right now. That it does have the rest machining.
Right, and then there was one. What about using the new contour feature for finishing in iMachining 3D instead of HSM?
Go in here. Rick, I think what you're looking at there is the 2D iMachining. So if I go to 2D iMachining, in the technology iRough plus finish here, we do have the option to do a finished floor with the contour that way. And I think that's what you were looking at, Rick, or hopefully. And if not, please let me know in the chat.
Yeah, you know, I was just going to say too, if there's anything that you guys need to take offline, just let us know. You know, totally no problem. You know, Kevin put his email address. I think you did, Kevin, in the
should be there for everybody
in the chat area. So yeah, feel free to email Kevin. He will be more than happy to to get back to you on anything that you'd like to see in further detail. So
yeah,
no problem.
I forgot to do a comparison here. Let me let's see, upper is not saved and exit. Yes, and here is our comparison of what we did before. So let me put these kind of side by side here. You can see much. It's a third of what's there. So, and I know we're kind of getting a little bit into the sales side of thing here, and I apologize, guys. I don't want to bring any sales or pushy sales into
easy
into the KevCAM night class. But like I said, we get. I've been working on Sean for a long time to give you guys a really nice discount for sitting through these Wednesday night classes. A lot of you guys have been with the night class since we started. Greatly appreciate it. And now here's a little bit of a thank you for that. So like I said, if you guys are on the fence, and Brent, I'm not saying you're pushy at all.
All right, man.
Here's your time to take advantage of a nice discount. So like I said, if you guys are curious on pricing or whatnot, shoot me an email, shoot your account manager email, but you have to let them know that you need the KevCAM end of the year special. So it's, like I said, it's our biggest discount we've ever done in SolidCAM, and there. That's your end of the year present.
Oh, that's all good. I think, Kevin, there's one last question that we didn't get to.
Okay.
Does HSM work on refs material unlike HSS?
Yeah, that's what I had pulled up there for you.
Oh, you did that. Okay,
yep.
Perfect.
So if I do add milling, HSM, and we have our rest machining right here.
Perfect.
So basically just looks at whatever was left over, doing a stock target comparison, kind of like the 3D iMachine does, and just machines off. That way you're not wasting any air cutting going on. And that's my favorite feature about this, is there is absolutely no air cutting at all that we're doing to this. I mean, none.
Well, yeah, and you can tell, I mean, just by the representation of that toolpath right there, I mean, if that's not the most efficient toolpath I've ever seen, I'm not sure, I'm not sure I've ever seen one. That's pretty impressive.
Yeah. So
of course, I'm biased.
Yeah. All right, guys, any questions, concerns, comments, anything at all? And I think our next class is, I don't know if it's after, I got to pull up the calendar here. So our next class is after Christmas, and we will be doing one. And, some of you guys might be traveling. I was kind of hemming on Han if I should do it, take a day or a week off or what, but next week we'll be doing one, kind of doing a little bit of an overview of the 5-axis simultaneous, 5-axis index heel. Obviously, I won't be able to cover everything in 5-axis, so we'll kind of do an overview first, and then what we'll do is break it into segments for you guys. So for those of you guys that can have the 5-axis module, there's a lot in there, so we'll break it down into each one. And like I was saying before, guys, we'll start off with HSS when we get into 3D, and we'll have just one segment on linear. We're going to do one segment on parallel to curve, one segment on parallel to surface, because I know there's a lot of stuff in here to really, make your toolpath even more proficient, getting you a better finish and whatnot. So I'd love to cover all HSS in a 1 hour class, but there's no way I can do it. So.
Yeah, there's a lot there for sure. And I think, Kevin, if I can just address one last thing real quick. Somebody had asked HSM, let's see, HSM, if you already have 3D eye machining and 3D milling. And that actually comes from William. We can address that offline. It depends on how your system is configured. So we can certainly address that, but again, like Kevin said, there is a promotion that's going on, and if there's an interest in full HSS, we can certainly prepare a quote for you and put you in touch with the proper personnel.
Yeah. So William, shoot myself an email. William, do you see my email in there? Yes, okay. Shoot me an email, and then that way I can look up your information and head it over to the account manager for you, and then they can get you the price for that. So, with that promo. So, yeah. And like I said, guys, before, this will be on the YouTube channel. So give it a couple hours; it'll be uploaded on there. Any questions, concerns, comments, feel free to email me. And not just related to KevCAM, but any SolidCAM or machining questions also. And like I said, I hope you guys have a great holiday. Look forward to the next class, and hopefully you guys can take advantage of that 20% off discount if there's something that you need. So if there's no other questions, guys, thanks again for taking the time out of the night to sit through here, and hopefully you got something out of it tonight. And like I said, we'll kind of keep diving deeper into the SolidCAM stuff here. So
yeah, very cool. Again, as Kevin said, just wanted to say thanks so much. It's we get a lot of people in these classes, and I'm really psyched to see a lot of people kind of taking some time after hours to do this. And obviously, Kevin, your time is very valuable, and appreciate you doing this.
Oh, thank you.
All right, man.
All right, guys. Well, have a great Christmas, and we'll talk to you guys next week.
Very good.
Bye, guys.